Alright, in this video I want to go over the Pascal's triangle, and the Pascal's triangle is just the convenience of expanding any binomial expression given in a general form of the term a plus the term b raised to an exponent denoted by capital N, where capital N's are positive exponential powers starting from 0 and then 1, 2, 3, and so on. Now, the way we use the Pascal triangles has something to do with the following form of the triangle. So we start out with the number 1, and then we start out with 1 and 1 right here. Now, to build up this Pascal triangles, the next step we want to do is that we want to take the most recent row, which is the second row, take these two numbers and repeat them on the side. But what's going to go in the middle is the sum of these two numbers from the second row. So the number in the middle for the third row is going to be 2, because 1 plus 1 is going to be 2. And we just, put a little red here, so we add them. Now, what about the fourth row? Well, the fourth row is still going to be having the two number ones on the side, like that. What goes in between is going to be two numbers. The sum of these two numbers and the sum of these two numbers. So 1 plus 2 is going to be 3 right there. 2 plus 1 is going to be 3. What about the fifth row? Well, same thing, we keep going. So we got 1 right here, 1 right there. In the middle will be the sums of every consecutive pairs of numbers of the previous row. So 1 plus 3 is going to be 4. 3 plus 3 is going to be 6. 3 plus 1 is going to be 4. So this go with that, this, that, this with that. That, and of course the same thing for on top as well. And then we keep going like that. To come up with the next row, we just have to take every pair of consecutive numbers and just add the two numbers, every consecutive two numbers together. So 1 plus 4 right here is going to give us 5. 4 plus 6 is going to give us 10. 6 plus 4 is going to give us another 10. 4 plus 1 is going to give us 5. And then of course you keep going just like that. So I'm going to crank out one more row. So keep the two number ones on the side still. And then just add every two consecutive numbers of the previous row together to fill in the middle of the current row. So 1 plus 5, that's 6. 5 plus 10, that's 15. 10 plus 10, that's 20. That's 15. And this is going to be 6. And of course, you keep going just like that, So I'm just going to put dot, 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 dot. So that's the way we come up with the Pascal's triangles. In the first row right here, we have the number 1. Well, the first row has all of the coefficients of the binomial expansion with the exponential power of 0. So if you're given a binomial expression with an exponential power of 0, so that stands for exponent. All of the coefficients in the expansion of a binomial expression with the exponential power of 0 is going to be 1. And that is true because anything raised to the 0 power is going to be positive 1 no matter what. If your binomial expression is raised to the first exponential power, then when you expand it out, all of the coefficients are going to be 1 and 1. When your exponent is 2, of the coefficients after you expand out your binomial expression is going to be 1, 2, and 1. And of course, this is going to be for exponent of 3. This is going to be when your exponential power of your given binomial is going to be 4. And this is 5. And this is 6. And you guys can see the pattern. So yeah, that is the idea of Pascal's triangles. Now, for example, if you're given a general format I mean, if you're given a binomial expression of the term a plus the term b raised to an exponential power of, let's just say 6, right? So if you have, so for example, if you have a plus b raised to the 6th power, well, it is going to be equals to, you know, like, you see, it is going to be, it's going to be having all of these coefficients. So you know you're going to have 1, 6, 15, 20, 15, 6, and then eventually 1. And what's going to go in the middle is going to be the first term. Well, I mean, starting from the left and starting from the first coefficient from left to right, from here all the way down to here. It's going to be the first term, but raised to the highest power, which is the degree 6. And then multiply by the second term, but it is going to be the lowest exponent, which is 0. And then plus the first term, plus the coefficient 6 multiplied by the first term and by the second term. But now the first term is going to be having degree 5, which is 1 less than the previous one. And then the degree of the second term is going to increase by 1, so this is going to be exponential power of 1. And then plus the coefficient 15 multiplied by the same two terms, a and b again. But now the degree of the first term a is going to decrease again by 1, so this is going to be 4. Decrease of the second term b is going to increase by 1 again, which is going to be 2. And of course you keep going like that, so this is going to multiply by ab raised to the third, and this is raised to the third, plus the next coefficient 15 multiplied by a raised to the 2, and then b raised to the 4, plus, and I do apologize for running out of room here. So this is 15 times a raised to the second times b raised to the 4th, plus the coefficient 6 multiplied by a and b again, but now a is going to be raised to the 1st and b is going to be raised to the 5th. And then of course, well, there's a plus 1 down here. Plus the last coefficient 1 multiplied by the first term a, the second term b, but now the degree of the first term a is going to be 0. The degree of the second term is now going to be 6. And that is how you use the Pascal triangles to expand out a binomial expression.